electricity feels invisible until the bill arrives. And lately, more homeowners are asking a simple question: is it actually possible to generate electricity at home instead of relying entirely on the power grid? The idea sounds appealing. Imagine producing your own electricity, reducing dependence on power companies, and having more control over how energy is used inside your home. But once people begin researching the topic, the answers can become confusing. Some sources claim it's easy. Others say it's unrealistic. The truth sits somewhere in the middle. Yes, it is possible to generate electricity at home. But understanding how it works, and what it can realistically provide, is essential before assuming it will power everything in a house. Tocy, it helps to start with how electricity normally reaches your home. Most residential electricity comes from large power plants that generate energy on a massive scale. These facilities may use natural gas, coal, nuclear energy, hydroelectric dams, or large renewable installations such as wind farms and solar fields. After electricity is produced, it travels through transmission lines, substations, and distribution networks before finally reaching homes and businesses. This system exists because generating electricity efficiently often requires large equipment and centralized infrastructure. Power plants are designed to produce huge amounts of energy continuously. A home system operates very differently. Instead of generating electricity for thousands or millions of people, a home system only needs to supply a single household. That may sound simpler, but the smaller scale changes how energy systems behave. The most widely known way to generate electricity at home is through solar panels. Solar panels convert sunlight into electricity using photovoltaic cells. When sunlight hits these cells, electrons begin to move, creating an electrical current. During the daytime, this electricity can power appliances directly or be stored in batteries for later use. Solar energy works well in many places, but it also has limitations. It only produces power when sunlight is available. Cloud cover, seasonal changes, and shading from nearby structures can all reduce production. That's why many solar-powered homes still remain connected to the electrical grid. The grid supplies electricity when solar panels are not generating enough power. Another method sometimes discussed is small residential wind turbines. Wind turbines generate electricity by capturing the motion of wind through rotating blades connected to a generator. In regions with strong, consistent wind, turbines can produce meaningful amounts of electricity. However, most residential areas do not have the steady airflow needed for efficient wind generation. Buildings, trees, and uneven terrain often disrupt wind patterns. Because of these limitations, small residential wind turbines are less common than solar systems. This leads some homeowners to explore a third category of solutions: smaller DIY electricity generators. These systems attempt to generate limited power using relatively simple mechanical or electrical structures. They are often built using accessible components such as small generators, magnets, coils, and rotating mechanisms. The goal of these systems is usually not to replace the entire grid. Instead, they are designed to produce modest amounts of electricity that can supplement household energy use. For example, a small generator might power lighting in a garage, charge batteries, or operate a few low-power devices. In some cases, people build these systems to better understand how electricity generation works, but there are important realities to keep in mind. Generating electricity, even in small quantities, requires a clear understanding of electrical principles. Voltage, current, and circuit safety all play important roles. Improper connections can damage equipment or create safety hazards. That's why anyone experimenting with home energy systems should learn the basic principles before attempting to build one. Another factor is output. Large power plants generate electricity using turbines that produce enormous rotational force. The generators connected to those turbines convert that motion into electrical power. A small home-built generator works on the same principle, but the scale is dramatically smaller. Because of that, the electricity produced by a small system will also be limited. This is where many misconceptions appear. Some online claims suggest that small home devices can completely replace grid electricity for an entire house. In reality, most small systems are better suited for partial energy support rather than total independence, and that brings us to the key insight: generating electricity at home is absolutely possible. The real question is not whether it can be done. The real question is how much electricity you want to generate, and what system makes sense for that goal. Large solar installations can power significant portions of a home but require higher upfront investment. Smaller experimental systems may be cheaper and easier to build, but they usually produce much less electricity. Many homeowners eventually realize that energy independence is not a single device or system, it's a gradual process. Some people start by improving energy efficiency inside their homes. Others install solar panels to offset daytime electricity use. Some experiment with small generators to understand how electricity production works on a smaller scale. Each of these steps contributes to greater control over household energy. The important part is understanding the structure behind these systems instead of relying on simplified claims. Electricity generation follows physical principles that apply whether a system is large or small. Once those principles become clear, evaluating different energy options becomes much easier. Home energy systems are not mysterious technologies reserved for specialists. They are simply combinations of mechanical and electrical components working together to produce and manage power. The more people understand how those components interact, the more realistic their expectations become, and that knowledge allows homeowners to make better decisions about how they want to approach electricity in their homes. If you found this explanation useful, consider subscribing to the channel. Here we focus on breaking down how energy systems work and what homeowners should understand before investing time or money into them. And if you're curious about how some people study small-scale generator structures or explore simple systems designed to produce electricity with accessible components, there's a helpful resource in the description that explains how these setups are organized and what parts are typically involved. It's a practical place to start if you want to learn how these kinds of energy systems are built and evaluated.